Hello, Accelerated Math 7-8 students. We are beginning our 11th video, and our 11th video is called Generating Equivalent Expressions, and this can be found on page 26 in my book. So I'm turning to page 26. Here I am. Generating Equivalent Expressions. Today we are going to use the commutative and associative properties to analyze and create equivalent expressions. The question that I want you to be thinking about in our lesson today is, what are the mathematical operations that can be moved around, making the order of an expression not matter? That's a tricky question. Let me read it again. What are the mathematical operations that can be moved around, making the order of the expression not matter? There's only 4 mathematical operations. So out of those 4, which ones can you move around in the expression and it doesn't change the outcome? That's what you're thinking about. All right, words to know. These are some information words that you must be able to know when you see them. They're all throughout your homework. They're all throughout your classwork. You just need to become familiar with these terms. So the vocabulary word that I would like to go through, I'm going to go through each one, and I need you to make this chart. So we're going to do vocabulary word, example, and definition. So first vocabulary word is a variable. An example of a variable is x. The definition is a symbol that represents an unknown amount. Okay? The next one, expression. An example of it is take 1/2 times the quantity x plus 8. An expression, the definition, a number sentence that is unsolved with variables and no equal sign. So an expression never has an equal sign. Equivalent expression, 12y divided by 6 equals 2y. 2 expressions that are equal to the same quantity. So if I took 12y and divided it by 6, what would I get? 2y. Does 2 times y equal 2y? Yes, so 2y equals 2y. 2 expressions that equal the same quantity. That's an equivalent expression. Term 4x plus 7 minus 8y. Terms are what makes the parts of an expression. And you'll notice that when I do the example, each term is identified by a different color and shape. So 4x is identified by a red heart. 7 is identified by a blue rectangle, and 8y is identified by a green triangle. The reason I did different shapes and different colors is because these terms cannot be combined. Right here, you have to write it in most simplest terms as 4x plus 7 minus 8y. You cannot go any further with this because none of these are alike, so you cannot combine any of them. So a term is parts of an expression. A coefficient, 2x plus 6y minus 3. A coefficient is the number that sits next to a variable that is being multiplied to. So the coefficient in this expression right here is the 2. A coefficient in this expression right here is a 6. Is this a coefficient? No, that's just a numerical value. Okay, so there's only 2 coefficients in this expression right here, the 2 and the 6. Okay, expression in expanded form. In expanded form, hopefully this is making you think back to about 3rd grade expanded form. So I have a plus b plus c plus c plus c. So expression in expanded form means a math sentence that has been broken apart to see all the terms. Okay? An expression in standard form would be 2a plus b plus 3c. So do you notice the difference between these two? Okay, this is expanded out. There are 2a's plus 1b plus 3c. This, in standard form, is how it's written when you compare the like terms. The like terms are the a's and the c's. So you have 2a plus 1b plus 3c. So basically, the definition of an expression in standard form is the simplified final expression. So you have to simplify it, which means combining all those like terms. Okay, there's still a couple more words that I need you to know of, but I had to go on to the next page. So numerical expression, 3 plus 6 is the example. A numerical expression is a math sentence with only numbers and no equal sign. Okay, and the last one, the value of a numerical expression, that means you solve it. So if you have 12 minus 4 equals 8, the answer to the numerical math sentence is the value of it. So the value of this one would be 8 because it tells you the answer. Okay, so hopefully those vocabulary words will become very, very important to you to the point that you just have them memorized in your head whenever you see them. All right, so the next things we need to talk about really quickly is the commutative property, and the reason I say quickly is because this is not the first time you've been around these, but we need to be reminded of them. The commutative property is the property that allows you to change the order in which you add or multiply numbers, okay? And so let's take a look at these guys. 5 plus 7 plus 3 plus 2. Well, let's do that one together. So we have 5 plus 7 gives me 12. Plus 3 plus 2. So now we have 12 plus 3 is 15 plus 2. And we have those, and I get 17. Okay? So now let's try it this way. So we have 3 plus 5 is 8 plus 2 plus 7. 8 plus 2 is 10 plus 7. And 10 plus 7 is 17. So what do you notice? The question that you have to ask yourself is, do these have the same answer? And if you look, lo and behold, they do. This one equals 17 and this one equals 17. So the question is, are these expressions equivalent to each other? And the answer to that should be yes. So why in the world does this one equal this one? What do you notice about 5 plus 7 plus 3 plus 2, 3 plus 5 plus 2 plus 7? What do you notice? What was the only thing that's different between them? If you answered that the numbers had a changed order, then you are correct. So this right here is an example of commutative property, that you can change the order of adding and you will still get the same answer. Okay? All right, let's try another one. The next one that you need to try, because we're doing both addition and multiplication, because those are the two operations that you can apply the commutative property to. Let's try the next two. Okay? So this time, you'll notice that we're multiplying instead of adding. So 8 times 4 is 32 times 2 times 9. Well, 32 times 2 is 64 times 9. 9 times 4 is 36. Regroup the 3. 9 times 6 is 54. Plus 3 is 57. So I know the answer to this one is 576. So now let's try this one. 8 times 2 is 16. Times 4 times 9. 16 times 4 is 64 times 9, and then 64 times 9, 9 times 4 is 36, regroup the 3, 9 times 6 is 54, plus 3 is 57, so we get 576 and 576. What do you notice about the two expressions? Do they have the same answer? The answer is yes. And are they equivalent expressions? The answer is yes, because they have the same answers. What do you notice? 4 times 8 times 2 times 9 is exactly the same as 8 times 2 times 4 times 9. So again, going back to that commutative property, the property that allows you to change the order in which you add or multiply numbers. And these two are the perfect examples of that. Okay, so that's the commutative property. Another property that I need you to be aware of and using is remembering that rule of subtraction. Okay, let me fold my paper again so you only focus on what we are looking at. So subtraction, I've been saying this, I feel like a broken record, but subtraction is the same as adding the opposite. So 7 minus a negative 4 is the same as 7 plus 4. Well, let's test it and see. So 7, that subtraction becomes a plus. The opposite of negative 4 equals 4. So 7 plus 4 is 11. Okay, what is 7 plus 4? 11. Are they equal? Yes. So you just proved that subtraction is the same as adding the opposite. Okay, and now division works the exact same way. We haven't spent as much time proving this with division, but division, and I'm hoping that you guys can think about this and say that it's true, is division is the same as multiplying by the reciprocal. Division is the same as multiplying by the reciprocal. So if we have 12 divided by 4, the question is 12 divided by 4 the same as 12 times 1/4? Now, why did I do that? The answer to that is, what is the reciprocal of 4? The reciprocal of 4 is 1/4. And it says division is the same as multiplying by the reciprocal. So 12 divided by 4 gives me an answer of 3, right? While 12 times 1/4 gives me an answer of 3. Does everybody see it? Okay, so we've just proven that division is the same as multiplying by the reciprocal. Okay, now, I know that's a lot of information, a lot of writing, but these are the things that you need to remember, because what we're doing is we're getting into a module where you're going to have to be able to just find and write expressions. You're going to have to find the equivalent expression to something, and so by using all of these tools to help you, you're going to be successful with that. Okay, let's go back to our question. What are the What are the mathematical operations that can be moved around, making the order of the expression not matter? There's only 2. What 2 are they? I should give you a very big, giant hint. Put it in front of you right now. Can we change the order on this one? No. Can we change the order on this one? No. Can you change the order on these? Ding, 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 ding. Yes. Can you change the order on these? Ding, 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 ding. Yes. So tomorrow, you guys need to be able to tell me, what mathematical operations can you change the order of the numerical expressions and it doesn't make the answer differently? Tell me the answer when I see you tomorrow. All right, that's it. I'll see you all later. Bye.